Hello everyone, welcome back to our discussion on chapter 2 polynomials. This is the second part of discussion of this chapter. Today we will discuss relation between zeros and the coefficients of a polynomial. Here we will take two important polynomials, quadratic and the cubic polynomials. You already learned in class 9 the general quadratic polynomial. What is a general quadratic polynomial? The general quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not 0. And the general cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. So to continue our discussion, let us take one quadratic polynomial, say x square minus 5x plus 6. If I compare this with the general quadratic equation, a is 1, b is minus 5 and c is 6. Now let us factorize x square minus 5x plus 6 by splitting the middle term. And we got the factors as x minus 3 and the x minus 2. It is clear that x minus 3 will be 0 when x is 3 and x minus 2 is 0 when x is 2. It means that the zeros of these polynomials are 2 and 3. Now let us see the sum of these zeros. What is the sum of the zeros of this polynomial? It is 2 plus 3 is equal to 5, and the product of these zeros is 2 into 3, that is 6. Let us take this. Also, if we calculate minus b by a, then we have got the answer as 5 and c by a as 6. Let us call this as second equation. From 1 and 2, we can say that sum of zeros is minus b by a and product of zeros is c by a. Now let us generalize the above relation, that is zeros and the coefficients relation, by using the general quadratic polynomial p of x equal to ax square plus bx plus c, where a is not equal to 0. If alpha and beta are the zeros of this polynomial, then we can write x minus alpha and x minus beta as its factors. Because x minus alpha, this answer will become 0 when x is alpha, and x minus beta will become 0 when x is beta. So these are the factors of the given quadratic polynomial. But here the coefficient of x square is not 1. Therefore, ax square plus bx plus c will become k times of x minus alpha multiplied by x minus beta. If we further multiplied x minus alpha and the x minus beta and grouping like terms, then we get the answer as k multiplied by x square minus alpha plus beta into x plus alpha beta. Now equating left hand side and the right hand side of the above equality, we can write k is equal to a, because k is the coefficient of x square on the right hand side and the a is the coefficient of x square on the left hand side. Similarly, dear students, we can also make another equation for the coefficient of x, which we have written here, that is minus k multiplied by alpha plus beta is equal to b. And after further simplification, then alpha plus beta becomes minus b by a. Likewise, equating the constant terms of the above equality, we can write k multiplied by alpha into beta is equal to c. Then after simplification again, we can write as alpha into beta equal to c by a. Finally, from these equations we can conclude that sum of zeros is minus b by a, that is minus coefficient of x divided by coefficient of x square, and product of zeros is equal to c by a, that is constant term divided by coefficient of x square. In the same way, we can establish the formula for cubic polynomial. Let us take the general cubic polynomial ax cubed plus bx squared plus cx plus d, where a is not equal to 0. So if I take alpha, beta and gamma as the zeros of this cubic polynomial, then x minus alpha, x minus beta, x minus gamma will be the factors. As we did in the case of quadratic polynomial, here again we can make the equality left hand side and the right hand side again, and after equating we got the answer as alpha plus beta plus gamma is equal to minus b by a, that is minus coefficient of x squared divided by coefficient of x cube, and alpha beta plus beta gamma plus alpha beta alpha gamma is equal to c by a, that is coefficient of x divided by coefficient of x cube, and alpha beta gamma, that is product of the zeros, equal to minus d by a minus constant term divided by coefficient of x square. So this way we can establish the relation between the zeros of a polynomial with the coefficients. In the next slide, let us learn about the formation of a quadratic polynomial when zeros are known. If we know the zeros of a polynomial, quadratic polynomial, then we can find the polynomial easily. How? Let us see that now. If alpha and the beta are the zeros of a quadratic polynomial, then x minus alpha and the x minus beta are the factors of that polynomial. So any quadratic polynomial satisfying this condition is k multiplied by x minus alpha multiplied by x minus beta. After simplification, we have got already the answer is k multiplied by x square minus alpha plus beta into x plus alpha beta. And here one thing we have to remember is k is not 0. And literally we can write as k multiplied by x square minus sum of zeros into x plus product of zeros. So this is the general formula for knowing the quadratic polynomial when the zeros are known. Among these quadratic polynomials, the simplest one is obtained when k equal to 1, that is x square minus sum of the zeros into x plus product of zeros. Say for an example, if 3 and the 4 are the zeros, then the quadratic polynomial will be x square minus 7x plus 12. Still we can have another quadratic polynomial 2x square minus 14x plus 24, etc. So we can have many more quadratic polynomials having the same 0, 3 and the 4. So we can conclude that the quadratic polynomial is x square minus sum of the zeros into x plus product of zeros, that is x square minus sx plus p. This is the formula for knowing the quadratic polynomial when the zeros are known to us. Thank you and have a very wonderful day ahead.